Hey, what's going on, everybody? It's Derek here, and we are now in week 4 of the SysOps Admin Associate Guide, where this week we're going to review storage that we did last week, and then we're going to go into databases. And I think this week it's especially important to review, storage that we talked about last week because it is very similar to database technologies and services, but there's definitely some key differences that we will go over, once we stumble upon them. Okay. So to review storage, of course, we want to start with S3. That is the main AWS storage service. It is an object storage service with virtually unlimited storage capacity and 4 different storage classes. Okay. You've got standard storage, which is just general purpose. It's used for regularly accessed data. Okay, intelligent tiering is going to use like the frequency of access of your objects to basically behind the scenes using machine learning determine when your objects should be moved between the standard storage and a cheaper storage class. Okay. It's best used for when the frequency of the actual access of your objects is going to be a little unknown, little unclear. You've got standard infrequent access, which is going to be used for data that's not accessed frequently. But if you do need to access data, it still has that low latency access. So you can get your objects out pretty quickly, but of course, you're going to pay a little bit more for retrieval because it's not necessarily designed to be retrieved often, okay? And then one zone infrequent access is similar, except of course your data is only going to be stored in one availability zone instead of being spread across at least 3 different ones, okay? And then you also have Amazon Glacier, which is similar to these, except it's used for archive data, data that you're not necessarily going to use or access very often. Maybe like you've got some kind of auditing process that happens once a year. You have some documents that you never use except for that once a year period. So you would just throw those documents in Glacier. Okay. There are different retrieval options that vary in price and time and the cost. And those options include expedited, which gives you your objects and your data back in 1 to 5 minutes. It's going to be more expensive because you're getting it back faster. Standard, which is about a 3 to 5 hour retrieval time, and then of course bulk is 5 to 12 hour retrieval time. Okay, and then of course with bulk you could export a lot more than you could with like expedited, for example. There are size limits. It's not important to know like the exact size limit of each sort of retrieval option, but just know that the longer it takes with standard bulk, you can retrieve more, okay? So S3 lifecycle rules are one of the best ways to manage costs in S3. It's an automatic method that allows you to move data between storage classes. S3 transfer acceleration is used in long distance S3 data transfers by using those edge locations that are just put in various cities all across the globe, okay, as part of that AWS global infrastructure. S3 versioning allows for multiple versions of the same object. It's important to note that you need to enable it on a bucket, and then once it's enabled, you can't disable it, you can only suspend it, okay? It allows you to easily recover versions of deleted files because you're basically storing the same file, but different versions of it, obviously. But because you are storing different versions of the same object, it's like having multiple objects technically, so you're going to pay for those extra versions, okay? So S3 security, you can have security at the bucket and or the objects level. All right, really depends on how in depth you want to go. You can control access with resource-based and identity-based policies. So remember, resource-based would be attached to, for example, a specific S3 bucket that's a resource, and identity-based would be attached to perhaps a specific IAM user. Okay. So bucket policies require a principal that basically defines the identity that's going to have access to that bucket. And then S3 ACLs allow you to control access to your buckets and specific objects within that bucket. By default, all public access to a bucket is blocked. That's something you would need to enable if that's what you want to do. Cross-origin resource sharing, otherwise known as CORS, allows specific resources from a different domain to access your S3 resources, okay? You can have server-side encryption of your S3 files and objects with either SSE S3, which is S3 managed encryption, SSE KMS, which is Key Management Service managed encryption, or SSEC, which is customer managed encryption, where you basically bring your own encryption keys and, of course, you manage them too. Okay. Elastic File System is a fully managed service to create shared file systems that have high scalability and low latency access. Okay. You can have EFS standard or infrequent access classes. All right, similar to those S3 storage classes. EFS lifecycle management automatically moves data between those classes, and it's similar to S3 intelligent tiering, and then it'll kind of do it behind the scenes for you based on how often you're accessing certain files in your file system. EFS encryption, of course, supports encryption at rest and in transit. The encryption at rest is managed with KMS, and then in transit is generally going to be SSL, okay, and TLS. EFS performance modes are general purpose, which is the default and the most commonly used. Max IO offers a virtually unlimited throughput and IOPS. Okay. EFS throughput modes. You have bursting throughput, which again is the default, and basically the throughput's just going to kind of grow as you store more in your file system. But you also have provisioned throughput, which allows you to burst above your allocated amount as defined by your file system size. So if you know you're going to have a high level of throughput on your file system, you're probably going to want to do provisioned throughput. Okay. All right, so Elastic Block Storage, EBS, you can have either SSD or HDD backed storage. EBS snapshots, you can take them either automatically or manually at any time, and the snapshots are going to be stored in S3, and if you want, they can be encrypted. Of course, that's recommended. But remember that any snapshot from an encrypted volume will be encrypted, and you kind of need to match like with like, so you can't create an unencrypted snapshot from an encrypted volume and vice versa, right? So you can't create an encrypted snapshot from an unencrypted volume, okay? And this is just a nice visual here on the different kind of features of SSD and HDD based EBS volumes. So definitely try to remember, not specifically the numbers in volume, size, and max IOPS, but for example, know that in SSD, okay, you have a higher level of IOPS, obviously, than you do in HDD. And then in HDD, you have, higher, you generally have higher amounts of storage available to you, okay? All right, so that is EBS, and Amazon FSX is a file system storage for specific cases. So typically, if you have an existing Windows file server, you're going to want to use like FSX for Windows file server because it's built on Windows Server and it can use, shared file storage that supports all Windows features and protocols like SMB. Remember that EFS is designed with Linux operating systems in mind. If you have Windows, you're going to want to use FSX for Windows, okay? And then FSX for Lustre is definitely pretty, specific in terms of its use case, but it's designed for compute-intensive workloads like machine learning, and it can handle massive data sets with sub-millisecond latencies, okay? AWS Storage Gateway is used in hybrid setups to manage storing data. So when you have some resources in the cloud, some resources on-premise, that's a hybrid setup. You can have file, volume, or tape gateways. And then within volume, you can have a stored or cached volume gateways, okay? The file gateway stores objects in S3, and then you can mount your drives to a bucket. The cached volume gateway uses S3 as the primary data stores, and it caches data on-prem for you to use. The stored volume uses your on-prem location as a primary data storage and uses S3 as a backup to the storage. I wish there was an easier way to distinguish between the two, but unfortunately it's one of those things that you just gotta kind of memorize it, but you see it enough and you'll just kind of know which is which. And then finally, tape gateways are sent to Glacier. It's meant for legacy stores, not really something you'll use very often, okay? All right, so databases. Let's get into these. So, databases. They're a little different from storage, and that with the database, you need your data to be at least somewhat structured. With storage, it's a lot more flexible in the data, structure it accepts. So for example, an S3 bucket, you could say like, hey, I want to store this image, I want to store this text file, and I want to store this EBS volume snapshot. Well, those are three vastly different types of things that you're storing, right? So you probably could mash those all into like a SQL database, for example, or if you could, it would be extremely challenging. I don't even know, honestly, if you could put like an EBS volume, for example, in a SQL database. So you have two main types of databases. All right, you have a relational or SQL, which has rows and columns. It's kind of like an Excel sheet, if you can picture that. And then you have non-relational databases, so NoSQL, which is similar to a relational database, but it works using key value pairs as opposed to like specific column formatting. You have other types of databases for specific use cases like Elasticache, Neptune, Redshift, DocumentDB, data lakes, and QL, so Quantum Ledger DB. These, you may get a few questions here and there on all these combined. They're not the core database services. The core database services are going to relate more to SQL and NoSQL solutions, okay? And generally, a database is used to structure data so it is easier to access and query, especially with larger data sets. Okay. So, AWS Relational Database Services. It uses an AWS service called RDS, and that provides you with support for the most common SQL-based databases like MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server. Okay. And then Aurora is a sort of a fork, Amazon or AWS's fork of MySQL and PostgreSQL, but it's fully managed relational database service. And currently, it only supports those two. Uh, no idea if it's going to, increase, their support for different databases in the future. It just remains to be seen. But right now, you can use Aurora with MySQL or Postgres. Okay. Aurora is highly available, durable, scalable, and secure, and it can, of course, be serverless as well because it separates the compute and the storage layer. That's more of a fun fact. You don't really necessarily need to remember that, unless you're doing like the database specialty, but that's another rabbit hole. Okay. So RDS is the most widely used RDS service in AWS. You can have a number of different database instance sizes, to fit your workload based around, whatever that is. But there's two different types of database instances, okay? There's general purpose, and then there's going to be memory optimized, all right? So RDS instances can be multi-AZ, which means your database will be deployed with a failover option for your primary instance to increase availability and resiliency. So basically, we'll talk more about this later, but basically multi-AZ is a good failover option for RDS. This failover process using the multi-AZ deployment is automatically done by AWS, and it will happen in examples such as the following. There's a few more examples we'll touch on later, but these two are kind of commonly asked of you on the test. So if your primary instance is being patched and is temporarily unavailable, it can fail over. And then if the primary database host you're using has a failure, it can also automatically fail over, okay? So like with any other service, RDS DB instances can be scaled up or down to meet demand. When scaling though, we need to consider both a storage and a compute perspective because that's kind of what goes on behind the scenes when you're running a relational database, okay? You have those two layers working. So storage autoscaling is going to be based around EBS volumes. Aurora is slightly different, in that it uses shared cluster storage. Again, don't worry too much about the technicals of that. Your storage can be general purpose, provisioned IOPS, or magnetic storage, which is really not recommended. It's more of like a legacy solution. Okay. And then you have compute scaling, which can be vertical or horizontal on an immediate or scheduled basis. So again, vertical, you can make your database instance bigger. Horizontal, you can add another separate database instance, maybe like a reader or something like that. And then you can do it right away if there's certain thresholds that get met and triggered, or you can schedule it for, maybe prime time during your business hours if you know that's when you get more traffic. Okay. All right, so consider setting up your own EC2 instances and EBS volumes instead of using RDS, which is again a managed service. If you need more in-depth control, or if you have a DBA on staff who kind of has like more experience. But for the most part, if your company is using some kind of relational database, RDS is going to be a good bet. Okay. All right, so RDS pricing options, that you have a few different purchasing options, just like you would with many other services. Some of these include on-demand instances, on-demand bring your own license, which is really just used with Oracle databases. Reserved instances, bring your own license, which again, Oracle database. And then you have serverless options, which is exclusive to Aurora for what we mentioned earlier, right, with the separation of the compute and the storage layers. But consider, remember that multi-AZ will incur additional charges because you're basically keeping a synchronized copy of your master database kind of up and running. Not necessarily available to be used, but it is up and running and being replicated synchronously, okay? But it's actually really nice and important to know that, for your backups, you're not charged up to your provisioned storage amount. So for example, if you have like 500 gigs of provisioned storage in your RDS instances, you'll have up to 500 gigs of backup for free. All right, so it's pretty nice. For reserved instances, there's 3 payment methods. So you can either do all upfront, which is a complete payment for 1 or 3 year period. It's of course going to be the largest discount. You have a partial upfront, which is some upfront, but you're going to have a smaller month-to-month payment. Okay, and then no upfront. Of course, you get the smallest discount, and it works based off of the hours you actually use your database instance. Okay, so there's definitely lots of nuances to RDS pricing, but essentially the bottom line is you're charged for how much you store and how much you provision to store. So even if you provision 500 gigs, you're still going to be charged for that storage, okay, even if you're only using like 100 gigs. And of course, how much you compute, how much you're doing, read-write operations, okay? All right, so let's actually go ahead and take our first break, and then when we come back, we will get into back in to it here. So we've got Amazon Aurora, which is similar to RDS. Okay, very similar. But it's, like I mentioned earlier, only designed right now to support MySQL and Postgres. I've already said this a few times, so I won't elaborate, but basically it separates the compute and storage layers, which allows it to be serverless if desired. And then it utilizes clusters for storage. You might get asked about that, but probably not. So wouldn't worry too much about the internals of Aurora. But for availability and performance, you can use Aurora replicas, which serve two purposes. Okay, they scale and support heavy read operations. Okay, which can obviously help your kind of master database, alleviate some traffic from it rather. And in case of a failure of your primary writer instance, okay, Aurora will automatically promote a reader instance to be a new writer. Okay. Pricing works similar to RDS in that you can use on-demand or reserved instances. Okay. All right. So AWS non-relational database services. It's kind of interesting that on the official study guide from AWS, for this exam, they say DynamoDB is excluded from being considered on the test, which I find hard to believe because it's an extremely popular service. So, and I'm pretty sure I was asked about it when I took my test, so this might be new, but we won't dive too much into it, but we will brush upon it so you're familiar with it and what it is. So it's a primary NoSQL database from AWS that's designed to be very fast, available, and scalable. And it can scale to billions of records with guaranteed consistent data return in seconds. Okay? DocumentDB is a NoSQL document database that's really just primarily used for MongoDB. Okay? So DynamoDB is that primary NoSQL service that's designed for low latency and high performance at a massive scale. Okay? It's also a managed service like RDS. All you have to do is set up your tables and configure how much throughput measured in read and write capacity units that your tables have. They only require a name and a primary key. Other than that, they are schemaless and they work off of attributes. So in other words, you can quickly modify items without having to redesign your whole table or stick to a certain data type. And you can also use secondary indexes for quicker queries if that's a requirement. And there's two primary differences to these secondary indexes versus RDS indexes. Okay? You can only use one index for each query. And when writing queries, you need to specify which index you want to use. So having said that, don't really think too much about that. That's more database internals. All right. Again, just maybe trying to get you a little bit over prepared here. But to refresh you on what key value pairs are, because this is an important concept. Okay, this is an important concept. It doesn't necessarily relate just to DynamoDB. For example, tagging uses keys and values, so it's important to understand kind of what key value pairs are. So a key is going to reference an attribute of an object, and a value is going to describe that attribute. Okay, so for example, a key here, it looks like this is describing a person. Okay, as a set of key value pairs. So you have one key with called name, and then the value of the name key is Bob. And then you have another key named age, the value is 25. Another key named job, he's developer, so on and so forth. Okay. And so that's all key value pairs are. It's pretty simple, but it really makes organizing things quite easy, and obviously running queries, it makes those easy as well. Okay. So there's two types of modes you can use with DynamoDB. You can either have provisioned, which basically allows you to specify the read and the writes allowed against your database tables per second by your applications. And it's measured in read and write capacity units, otherwise known as RCUs and WCUs. And then you have on demand, which is you're not going to provision any R or WCUs. It's more expensive, but it's recommended for unpredictable workloads. But over time, you want to try to go up to provision. Okay. When selecting provisioned, you can specify how much R and WCUs you want to autoscale to based on the utilization percentage of your tables. Okay. And then your data is automatically replicated as 3 copies in 3 availability zones, which leads to eventual consistency. Okay. All right, DynamoDB Accelerator, otherwise known as DAX. It is an in-memory cache delivering performance up to 10 times as fast as the default DynamoDB settings. All right, so it's mostly used if you have a requirement for microsecond response time and very read-heavy workloads. And it works by using node clusters that each manage their own cache. And technically, it's a separate entity from DynamoDB. So you have your DynamoDB tables, and then you'll also have your kind of accelerator that's caching things. Okay, so right here you have the accelerator communicating, pushing things to the nodes, and the nodes are over here managing each, of their own caches. Okay. All right, so Elasticache is an in-memory caching service that allows you to accelerate application and database performance using temporary data. So it's primarily done by improving read-only performance, as an in-memory cache can serve this info much quicker than continually requesting info from a persistent data store. So real quick, I just want to make a differentiation. So you have Elasticache, which is primarily used to cache data in front of a database to speed up, kind of queries to that database. It would normally maybe be like read-only queries. Right? But then you also have like CloudFront, which caches things in a different way. It just caches actual content close to your end users, as opposed to Elasticache that's going to cache content, in front of a database to help database performance. All right, so they're both caching services, but slight differentiation there. All right. Elasticache supports Memcache and Redis engines, with Redis, offering a little more features. So here's some use cases of each. So Memcached is pretty simple. It's used if you just have a pretty basic and straightforward caching requirement, right? Or if you need to utilize session stores. Okay. But Redis obviously does both of those, but you could also utilize chat and messaging protocols, machine learning, media streaming, and queues. So if you just want like something that's simple and high performance, go with Memcached. But if you want something that's also high performance but more robust, use Redis. Okay, that's kind of how I remember it. Redis is more robust. All right. So Elasticache has a few different node components to it. So the main unit is a node, which is the primary unit. And it's essentially a fixed size chunk of secure network attached RAM that basically handles operations. And then a shard is actually a group of up to 6 Elasticache nodes. Okay, so if you have a higher load, you can group a few different nodes into a shard. And then a Redis cluster is going to be a group of either 1 through 90 of these Redis shards. And then a Memcache cluster is going to be similar, except it's just going to be a collection of one or more cached nodes. Okay. And then, so real quick, don't worry too much about like the components of Elasticache. Just remember like nodes and shards. That's kind of the big difference there, or the big takeaway there. All right, Amazon Neptune is a fast, reliable, secure graphing database service. So, think of forming relationships between data. So some common use cases include like social media connections, credit card fraud detection, and product recommendations. So for example, I know we've all been on Amazon and we see, oh, based on your purchase history, you may like these things. Or, so it uses a graph database to say that, based on this thing you bought, other customers also, bought this thing, but those customers bought these as well. So it kind of graphs, your relationship and your other customers' relationship to this one common product to then say, okay, you might like these other things that customers bought. And then social media, same way, or same idea, right? You have a person that you're friends with and other persons are friends with, so it starts recommending their other friends to you because you have that mutual connection. That's kind of what a graph database is, all right? And it works using clusters that use primary and replicas. So you've got a primary cluster and a replica cluster. And the replicas are only read operations, like most replicas usually are. Each cluster, though, does have multiple volumes. All right. And you can connect to your database with 3 different types of endpoints. So you've got the cluster endpoint, which points to your current primary database instance of your cluster. It's used for apps that need read and write access. You've got a reader endpoint, which, as you might guess, it connects to read replicas, and it's used by apps that only need read access. And then you've got an instance endpoint, which lets you go directly to a specific instance in your cluster. Maybe you've got like a load balancer that you need to direct specific traffic, kind of around. That maybe when you use an instance endpoint. Okay. Redshift is AWS's fast, fully managed data warehousing service designed to handle extremely large and complex SQL queries. So queries that are more than just kind of simple transactional things like in a database, relational database. But this is more for like analytics processing and big data. All right. Data warehousing is based on ETL jobs, so extract, transform, load. Uh, and that's basically kind of how you handle your data, prepare it to be analyzed, and then actually analyze it. Okay? So you first extract your data by taking it from many different sources and loading it into a staging area, which is commonly like a data lake, for example. And then you transform this data, right? So you map it, you reformat it, you conform it to your data structure standards and other processes that your company might have to basically prepare this data to be more easily consumed and queried. Okay? It's easier to run large complex queries if all the data is kind of structured similarly. And then finally, you load the data, so you just insert this transformed data into a target data warehouse where it can then actually be queried and analyzed, and the magic sort of happens. Okay. So Redshift has a few components as well. You have clusters, which are the main component of the Redshift service, and it basically runs its own engine and it has at least one database in it. Okay. Compute nodes, when you get a few groups of compute nodes, it forms a cluster, and each cluster is going to have at least one compute node. Each node has its own memory and storage capacity, so it's kind of like those nodes in Elasticache. A node slice, though, is a partition of a compute node where the node's memory and disk space is actually split. Don't worry too much about that. And then you have a leader node, which is where if a cluster has more than one compute node, there's going to be one leader node that kind of facilitates the communication between all your other compute nodes and even external applications that are accessing your warehouse to do querying. Okay. Document DB. So this is designed to store JSON document-based data where you can then query and index it. It does contain compute and storage layers, but they are decoupled similar to Aurora, so you can scale them individually if needed, or together, obviously. And it's designed to have full compatibility with MongoDB. So if you get a question saying you need support for MongoDB, start thinking DocumentDB. Okay? It's similar to Neptune in that there are database clusters that have their own sort of cluster storage volume. And you can also have replicas across multiple availability zones. You also have the same three types of endpoints as Neptune. So you've got cluster, reader, or instance endpoints. And again, if you need to remind yourself what those are, here they are. Okay, cluster, reader, instance endpoints. Okay. Data lakes. So a data lake is a place to store and collect data that can be either structured or unstructured. So it's just a giant conglomerate of data that you just put all your stuff there and you figure out what to do with it later. It's different from a data warehouse in that a lake, again, is a place to store any type of data. But when you're using a warehouse, that data needs to be structured in a certain way because you're running basically complex SQL queries. And SQL is standardized query language. So you need to have kind of standardized, formatted, and they call it clean data. Okay. And typically, a lake is going to be a good data source for your warehouse to pull data from, and then, do the ETL operations on it to clean it up and then analyze it. All right, data lakes essentially, seek to solve 5 challenges. So just massive storage solution, okay, for any type of data, basically. Data movement, so if you need a place, again, to just move data into, keep it there for later, and then pull it back out again whenever, you can use it for that. Data cataloging and discovery, you can build out your lake in a way to format what you put in there in a specific way. And then you can, of course, use it for generic and predictive analytics as a data source over data warehouse, for example. Okay. So AWS, excuse me, Lake Formation is a service that identifies data sources in S3, RD, relational databases, and NoSQL databases that can be moved into a lake. All right, once it identifies those candidates, it will do what's called crawling using another service called AWS Glue, which we definitely don't need to talk too much about. But it basically crawls through this data and then catalogs it so you can more readily perform analytics on it. So just makes your lake a little more structured. And then when ETL is needed, think AWS Glue. That's kind of Glue's main job is ETL operations. Okay. And then lake formations work off of blueprints, which basically do the following. Okay, so you discover the source table schema, you automatically convert that to a new target format, you partition your data based on the partitioning schema that you're going to use, and then you finally keep track of data that's already been processed so you don't have a lot of repeat operations happening, especially if you have a lot of data in your lake. If you're doing repeat operations on the same data, then that will be unnecessary costs. Okay. All right, so let's take our second break here, and then when we come back, we're going to talk more about database and RDS concepts that are going to be quite helpful for us as SysOps administrators. Okay, so let's take a break for a few minutes, and we will be right back. All right. All right. Let's see if we can finish up here in this last 15-20 minute work stretch. All right, we're almost to the end. I know we are. All right, so now we want to talk about some concepts that really apply specifically to SysOps administrators. Okay. Because part of being a SysOps administrator is not only knowing, what the appropriate solution is, but you also want to keep in mind things like business continuity and reliability, disaster recovery procedures. So it's important to kind of understand how these relate to your databases because your databases are more than likely a very key and very critical component to your overall company's solution, okay, or application. So when we think about availability, specifically high availability in RDS, we want to remember that your data is crucial to any business. Okay, it doesn't matter what it is, you need your data. Okay, that's just welcome to the digital age. So your data must be in a continuously highly available state, right? Otherwise, things will be out of sync. Things won't work right. It'll just be a poor customer experience. You don't want that. So with RDS, there's two primary ways to achieve a state of high availability. Okay, you can use multi-AZ deployments, or you can use read replicas. And that's not to say you can't use them together, but because they're both important, you can use them together, but they have distinct differences, okay, and purposes rather. So, uh, multi-AZ deployments. So the purpose of these is to use them as a failover option. So it consists of two pieces of minimum. You have a master database in availability zone 1, so whatever availability zone in whatever region. And then you have a standby replica in availability zone 2. So it's in the same region, but obviously a different availability zone. The data replication between your master and standby replica is synchronous, which means that they are updated together at the same time. And the failover process happens automatically via AWS. Okay. Uh, so I mentioned a couple scenarios earlier, but here's pretty much all the scenarios that this failover process can kick in. So if you have patching maintenance, a master database host failure, an entire availability zone failure, so if all of AZ1 went down, obviously it'd kick in to use AZ2's replica as the new primary instance. So if your database instance gets rebooted with failover enabled, that'll trigger it. And then if your database instance class is modified, it's also going to fail over while those changes are implemented in your first database. Okay? Also note that Aurora builds this fault tolerance in by default, so it's not necessarily something you need to specify if you're using Aurora. Okay. So RDS read replicas, the purpose of these is to offload read traffic from your master database. Because typically, when we think about databases, read traffic for like functioning applications is typically the highest load that it's going to experience. So it's just a way to offload some of that. But read replicas are based on a snapshot of your master database, which leads to asynchronous replication. So in other words, there's a little bit of replication lag. In other words, because like in a multi-AZ deployment, you've got this master and standby databases being synchronously updated, so updated together. With read replicas, it just takes periodic snapshots of the master database, so it's only going to be as relevant as the latest snapshot. Okay? But you can have multiple read replicas across multiple regions, which is nice. And then you can also have nested read replicas. So you could have like a read replica here, and that read replica could have like two more read replicas reading from it. It really just depends on how much you have going on with your databases and your application. Okay. You can manually promote a read replica to become your primary database, but this is kind of one of the key differences between read replicas and a multi-AZ deployment is that this cannot happen automatically. So there may be some delay, there may be some increased, RTO, RPO because of this. But that's potentially where you start to work them together, right? You have a multi-AZ deployment ready to go, so there's absolutely no downtime, and then you have a read replica which offloads that read traffic from your master database, so that you can maybe avoid some performance issues and the need to fail over to another database in the first place. Okay. All right, so RDS backup operations, it's very important for business continuity. So that's an important term AWS likes to throw around. Basically, it just means, the business that you are working for and part of continues to operate at expected levels. Okay. But it's also important, to have defined backup and recovery procedures so that you're not just doing this stuff on the fly and you run into issues. Okay. So there's three ways you can back up an RDS instance. There's automatic, which is kind of what you see here. You can specify in the console or obviously in the CLI if you're using that, how you want it to handle your backups. Okay? You could do manual snapshots, which we'll look at that in the lab that we have for those. And then the AWS backup service, same thing. We'll look at that for the lab. But there's multiple ways for you to back up your RDS instances. So, in terms of critical workloads, critical production databases, there's no reason you shouldn't be backing them up, okay, one way or another. All right, so AWS Backup is a central hub to manage backups across your environment, across multiple regions. Okay, you can use it to assist with compliance and consolidate the logging of your backup operations into a single place. And it consists of the following. Okay, so you've got vaults, which basically organizes your backups, okay, similar to like a Glacier vault. A backup plan, which states and specifies how a backup occurs. Backup selections are where you specify what's actually going to get backed up. Backup jobs is the actual execution of your plan. Recovery points are versions of your data that you can restore. And then restore jobs are the actual execution of your restore requests. Okay? And then AWS Backup supports DynamoDB, RDS, EFS, EC2, and Storage Gateway. So pretty much any database or storage service, aside from S3 obviously, is going to be supported by AWS Backup. Okay? So RDS Performance Insights provide visibility to the performance of your SQL queries inside your RDS databases and the subsequent load that those queries are having on your database instance. So this gets a little bit more into database internals, so we won't go too deep down this rabbit hole, but just know that you can use performance insights together with RDS enhanced monitoring, which that is going to gather info about your database's operating system, so kind of the actual hardware. So the utilization, the free memory, etc. Right? So you can see, from enhanced monitoring, what's happening to your hardware and your instance, and you could see from performance insights what may actually be causing that event or set of events to be happening. Okay. Performance insights uses dashboards as the main method of visualization to what's going on. And CloudWatch actually has the metric database connection if you want to see how many people are connected to an RDS instance. So that is kind of a helpful metric. It's kind of annoying that it's separate in CloudWatch, but important to know there. Okay. All right. So database summary. We could actually finish this section within an hour, guys. All right. So Amazon RDS. Let's just get through this real quick. So it's the relational database service to create scalable databases. It supports MySQL, Aurora, PostgreSQL, MariaDB, SQL, so Microsoft SQL Server, and Oracle database. You can have a database in a single availability zone or multiple availability zones. It's up to you and your business requirements. Aurora is a serverless database option designed to scale your compute and or storage layers. And then multi-availability zone failover happens automatically to prevent downtime. So, for example, again, if that primary database has a host failure, okay? Aurora is a distributed, fault-tolerant, and self-healing storage system that automatically scales. It replicates your database across 3 availability zones, which is huge for that durability and fault tolerance and reliability. It's got continuous backups to S3, and it supports currently MySQL and PostgreSQL. DynamoDB is the NoSQL database service designed for ultra-high performance and single-digit latency, commonly used for like gaming and IoT. Works using tables and primary keys with an option to use secondary keys for increased performance. You can customize the provisioned throughput levels of your read and write capacity, and of course, remember it works with RCUs and WCUs, so read capacity units, write capacity units. It's primarily spoken to and sold as being fast regardless of the size of your tables, and you can use that accelerator as an in-memory cache to improve worldwide performance. Okay? Elasticache is a caching service using in-memory data storage. It's generally used to improve read-only performance of your databases. Currently supports Memcached and Redis. So Memcached is more simple. It's just used when you need a nice caching service with a high performance sub-millisecond latency when the speed and performance are top priority. But if you want more featureability, a more robust solution, start thinking of Redis, which also offers a high performance sub-millisecond latency product. Okay? So just know that if speed and performance are your top priority, you don't need a bunch of features, memcached. Otherwise, if you need a robust solution, think Redis. Okay. And then Redshift is that SQL-like data warehousing service that's used for massive and complex queries. So just big data. All right. All right. So that brings us to the end of this week. And next week, as you can see, we're going to go over networking. And as you can see, guys, we didn't necessarily review a ton of the other services like, document DB and things of that nature because, you might be asked about them on the test, but you probably won't. We really just want to cover what you will for sure be asked about on the test so you feel confident in that and you're strong in the areas that you're going to be tested on. Okay, in regards to the other sort of minor database solutions, like data lakes, again, document DB, whatever, just kind of know what they're for from a high level, but you don't necessarily need to know all the specifics like you do with, these and obviously RDS, okay? And a little bit of DynamoDB. All right, so hopefully that's helpful, guys. Be sure, of course, to do the labs that accompany this week's lecture, and we will see you next week for networking, okay?